Welcome to today's webinar on mainframe application modernization. I am Dustin Froyam, and I'm glad to have my colleague and co-presenter, Vince Ray, on. Vince is also a co-founder and the CTO of VirtualZ. And also on the webinar today is our CEO and founder, Jeannie Glass. So we have a lot to cover, so I'm going to jump right in. So we're going to talk a little bit about the challenges of mainframe application modernization, and then we're going to go through some very specific use cases or patterns around data access that we help with. And then we'll review some of the benefits that we have discussed, and then we'll have time for a Q&A and some conclusion. So let's just talk a little bit about challenges in application modernization. So if you are moving data to a new target, how do you quickly get that data to that target for test dev, final cutover? That can be very complex, costly, time consuming, expensive. And so, how do you deal with those challenges in modernizing applications? And especially in this day, particularly with mainframe resources being scarce and you have higher order priorities for them than modernizing applications off the mainframe or back into the mainframe potentially. Then you have challenges if you have shared data. So if your SOR remains on the mainframe or your SOR is off the mainframe, but you need to share data back to the mainframe, how do you do that in today's available targets, tools, etc.? Do you have to go with a legacy ETL method and change data capture, or is there a better way to do that? And then if you're processing in two different compute environments, whether that's cloud distributed plus your mainframe, how do you deal with disaggregation of data and those applications, particularly if you have a shared SOR still from a data standpoint? And then security, we hear from a lot of customers concerned about, once they ETL that data out away from their mainframe, how do they deal with security? Do they have just multiple copies floating around of, your most valuable data resources on the mainframe? All right, let's jump right into our first use case, which is, let's just talk about probably the simplest one, which is the permanent one-way migration. And so you're moving an application off the mainframe, or you're doing a cloud native distributed application, but you need mainframe data to support that. And so how do you get that data into your test dev, even if you don't have to share it after that point, or final cutover, you don't have to share it. And then in this case, you don't have to do any updates back to the mainframe data source. So there's no change data capture or anything like that. So how do we easily and efficiently get that data to your test dev environment and the ultimate target? So Vince, I'm gonna ask you to kind of share what your thoughts are about this and how we solve this data access pattern for the most simple application migration or cloud native development.
Yeah, no, happy to speak to that a little bit. I mean, normally, let's not forget that what drives this is complexity. It's not too many mainframe applications exist where the data doesn't get consumed by multiple applications. So you might have a whole family of applications living on your mainframe that are trying to share data, and you want to migrate, let's say 1 or 10 or some percentage of those applications out to some other platform. How do you do that without disrupting the existing applications is kind of what we're talking about here. So, as you laid out pretty well, Dusty, sometimes those are really direct things. All I need is a snapshot of my data that starts out on the mainframe and ends up in really whatever format I want it to end up in. If I'm rewriting some kind of dusty old mainframe application, I'm probably doing it in a more modern way. So I want that data, maybe in a relational database, or I want it in, a modern NoSQL environment, whatever the target might be. And that's where our PropelZ product comes in. PropelZ can take pretty much any type of mainframe data and transform it in such a way that it can be stored in just about any popular database repository. There are about 100 different database targets that we can work with out of the box. That's everything from the traditional databases, Microsoft SQL Server, MySQL, Oracle, those types, all the way to kind of more modern, NoSQL databases, Hadoop or MongoDB, or just about anything can be supported with PropelZ. So this gives you a way of going from VSAM, let's say, record-oriented data, to more structured data or unstructured data that lives in a more modern repository. We supply everything you need out of the box. We give you, as a new PropelZ customer, you'd see that we ship 5, I'll call them certified environments. Uh, MySQL, Postgres, Microsoft SQL Server, Oracle, and Snowflake are the 5 that come right in the box. But really, it's open-ended. We can do that extension work, or you can do that extension work. What it really comes down to is supplying an appropriate JDBC driver, and then there's some configuration data that controls the database queries that we generate. That's makes us adaptable to nearly anything. PropelZ also includes our data transformation engine, so that data you're starting with is probably really complicated. Mainframe, let's say VSAM. If we look at a record in the VSAM file, it's probably many things. It might have some text data. That text data might be encoded in EBCDIC, and you need to rethink that as you're going to whatever your target is. Might need to go to UTF-8 or some ASCII encoding. That's part of it, but that's not all of it. That record might have binary fields. It might have packed decimal fields. It might have mainframe style, I don't know, timestamps or floating point, or whatever it happens to be. So one of the other really key features of PropelZ is that you can give us a little bit of metadata that describes those records. And when I say metadata, we're talking nothing beyond a very simple COBOL copybook, for instance, is all we need. And we can use that information to understand the records at a column by column level, and then transform them to whatever the target expects. So I'm going to, let's say, an Oracle database. What I'll see on the target isn't just, here's a blob that matches what that original record was. If you need that, you could do that. But I suspect more people will be happier to see that record broken out into the individual columns, the individual fields that were in that original record, and then stored in the database as the correct types. So if I had, let's say, a mainframe style floating point number in that record on VSAM, it ends up in the database as a float in that particular column, and on and on and on that way. So that data transformation, is very handy when you're going to a database. If you're going to something that's not a database, let's say instead of going to a database, you want a Kafka transaction or an MQ transaction or some of that kind of stuff. You might not want kind of a SQL representation of the data. We can also use the transformation capability to give you records as JSON objects, or as XML objects, or CSV, or really whatever format makes sense to you. So the idea isn't just take the raw data and get it somewhere. The idea is take the raw data transform it so it's as useful as possible, and then store that anywhere that you want. Now, one of the other things we get into, and Dusty touched on a little bit of this, is sometimes you're dealing with a lot of data. Sometimes some of these mainframe files and things could be terabytes of data that have to be dealt with. And the last thing you want to do is update that on a regular basis, that whole file on a regular basis. So, we also give you the ability to do subsets of your data. So, just as an example, I might have, let's say a transactional journal, all the transactions I process over time. You can certainly do things like uh, look at that data and uh, process some of it, and then an hour later come back and say, give me everything in the last hour that I haven't seen yet, and just pick up a handful of records, or however many you are. That makes it much more convenient to run PropelZ in this mode where it's scheduled on a regular basis. And instead of having to deal with terabytes of information, it's only dealing with whatever's changed in the last period. You could do that by keys in the input file. You could do it by record numbers. There are actually a lot of ways that can be done, but it makes that whole process much more manageable, and it kind of eliminates that need to deal with all of the data every time that you process it. Uh, just moving through some of these other points. I mean, PropelZ can run. It's really simple. You can run it right from the command line if you want to. You can log into your mainframe, type in a PropelZ command. Take this file using this metadata, and I want to go to this target, and it's done. You can also do scheduled kind of things. A lot of sites might have, let's say a batch job that runs once a day and creates important files that you want to synchronize with something in the cloud. Well, you could just add a step to that kind of process to run PropelZ, and now at the end of that, when your files are created, PropelZ runs, does its magic, and a copy of the data is going to exist in whatever targets you want. So, a lot of flexibility there. You can run, multiple PropelZ, certainly concurrently, one after the next. You could run, some that go to Oracle, others that go to Snowflake. I mean, really, the sky's the limit that way. Throughput, I mean, one of the other advantages of PropelZ is that down at the network level, the protocols we use are based on industry standard JDBC transactions. And JDBC is a standard that's designed for moving lots of data in and out of databases. It's efficient, it's a binary protocol, it's designed to deal with big records, lots of caching, all of that. Many of the competing products in this space use things like HTTP to move their data around. And HTTP is basically a text-based protocol that's designed for web transactions. It's not really designed for large amounts of binary data. So we find that we have a pretty significant throughput advantage over some of the competitors. Just to kind of put some numbers to it in our environment, and understand that as a small company, we don't exactly have a big mainframe. We have literally the smallest possible mainframe it's possible to have. And from that, going to a database hosted on Amazon's free tier, with nothing more than consumer grade gigabit Ethernet, we can get somewhere in the 6 to 10,000 record per second range, and that's with large records. That's with 1K record sizes. If we had records that were more like, I don't know, 80-byte records or a couple 100-byte records, that number would be huge. So, we believe on a serious mainframe with 10 gig or much higher bandwidth connections than we have, it's possible to achieve whatever throughput the target can withstand. And then, one of the other things we often hear is that, people are moving, at least in some cases, they're migrating applications off the mainframe to save money. So last thing they want to hear is that first thing you need to do is run this big, expensive, resource consuming new workload on my mainframe to support that. So we've been careful to architect PropelZ to be zip eligible. The code executes on an IBM specialty processor. And what that means is that running PropelZ, you can run all the PropelZ that you want, and it doesn't cause your mainframe software bills to climb. It's not like running PropelZ is going to drive up capacity, and now your ZOS software bill, and on and on and on, get more expensive. PropelZ gets steered to an available zip engine inside your mainframe, and that doesn't, I call it spin the software meter. So very very cost efficient way of running this type of stuff. Not only you get the benefit of whatever you're migrating off of the mainframe, but you're doing that by reducing MIPS consumption under ZOS at the same time. So a win all the way around. So Dusty, what did I forget, or
Yeah,
anything you want to?
I just had one question for you, Vince. So, you and I were just recently talking to a customer that, it took them weeks in a traditional ETL model to, get their data mapped and get it over to, their target. Can you just talk to the kind of the implementation and the time to value with PropelZ?
Yeah, that's a great point. I mean, and I remember the call you're talking about, and I felt so badly for the poor customer there. They, clearly had a lot of scars from literally spending weeks figuring out how to get mainframe data where they needed it to go. Uh, with PropelZ, it's different from that. Let's say you have an existing, I don't know, vSAM file, and you have a COBOL copybook that tells us what those records look like. I mean, literally minutes later, you can have a database wherever you need it, populated with those rows all broken out into the columns, as we find in the metadata. I would invite everybody on the call. We have a little video showing PropelZ, and what we've done is we have a vSAM file that has a record for every airport on the planet. There's 76,000 and some. And the reason we chose that data is it's complicated data. It has names, it has URLs, it has things like floating point numbers for latitude and longitude. It has binary numbers for, like, elevation above sea level. It has all kinds of complex data. And you'll see in real time in our video, from sitting down with here's the copybook, here's the data, to that being done is literally a couple of minutes. And what we do, and probably half the demo is, now that I've got the data here, what do I want to do with it? And we show it being processed in a tool like Tableau to do custom charts and graphs and so forth. So again, if you got a clean COBOL copybook that describes your records, this isn't something that you're going to spend weeks doing. This is something you're probably going to spend minutes doing. And there are things you can do. You might try different network buffer sizes to make it run a little faster. There are those kinds of things that you might do a couple of runs to see what's optimum. But getting the basics going is really really a trivial operation here. So yeah, that's really an important point. Is you could sign up for PropelZ and be up and running in an hour, and being looking at your data on whatever target you want, yeah, certainly the same day, if not the same hour. So Yeah, definitely a huge productivity gain if you're used to, looking at a file and trying to figure out what does this look like and trying to make sense out of it, maybe writing code to do those kind of things. I mean, if that's your model, then PropelZ is going to save you just a huge amount of time and energy. And, not just that, but, in a lot of cases, these aren't one-time things. These are, I get that all figured out, and then 2 weeks later, somebody adds field to that file, and I'm, dealing with it again. Yeah, again with PropelZ, I just don't worry about that stuff. I just, point to the metadata, and I'm done. I add a field, I put something new in my COBOL copybook that describes the field, and I'm done with it. There's no, you know, coding. There's no manual effort there other than maybe changing the parameter you pass to PropelZ. So yeah, great point, Dusty. And yeah, sorry to go on and on about
No,
that.
no, all good.
Right.
So I'm gonna just briefly touch on one of the reasons why we're different in the market is we actually publish our pricing. And so PropelZ is, it's an extremely high value product. Not only all those things that Vince just discussed, but it's only $50,000 a year. It's not MIPS based. It's not MSU based. It's not LPAR based. It's really an enterprise license, unlimited data. And as Vince said, we give you those five, let's just call them certified drivers out of the box. If you need other ones, we're happy to discuss certifying those as well. But yeah, it's an extremely high value product for a pretty low cost of $50,000 per year. Okay, Vince, I'm going to move on here to our second use case. So get ready. So this is a little higher order um, and more complicated use case. So you got shared data across the platforms, and let's just assume you're permanently migrating or again having a cloud native, but you also need to potentially update that data back to the core SOR on the mainframe because it is shared data. So how do you consume that? How do you update it? And then, how do you deal with that from, over the historic ETL change data capture processes that are often, complex and fragile in some cases. We often hear that is they tend to be very fragile in their implementation. So Vince, how do we attack that one? Um, and what's really kind of different about how we go about this?
Yeah, and so at a high level, this is where our Lozen product comes in. Lozen takes your mainframe data and without replicating it anywhere, it just stays where it is. And all of the operations happen against that single copy of the data. So if I've got I don't know, transaction I want to run out in the cloud someplace and it needs to read a record, update the record, and kind of move on, all of that's happening against a single copy of the data. So there's no issues of, it gets out of sync or how do I get the update back to my mainframe, that kind of stuff. A lot of the other techniques you're talking about, I might do what I just described with PropelZ. I'm going to start with a copy of my data. I do some updates against it, but now I have this enormous problem of how do I get those updates back to the mainframe? It's not hard to get the updates themselves back. What's hard is knowing that some other application hasn't come along while I'm doing my updates and updated the same records. And now, whatever I do, I have to reconcile that. Which update do I want? Do I want the one that happened in, I don't know, a mainframe CICS transaction while I was running in the cloud, or do I want the one the cloud created? So, people invent these massively complex processes to deal with the updates. Uh, with Lozen, none of that's necessary. There is only one vSAN file. So when I read a record, I'm getting the current record. And when I update the record, I'm updating it in place on that vSAM file. There's no chance of integrity exposures or any of that sort of thing. In addition to that, with let's say we could solve this problem of the updates, and so the model gets to be, I transfer all my data to the cloud, I run a bunch of updates against it, and then I transfer it all back. But the subtle problem with that is I'm making many passes through all of the data. That transaction I'm running in the cloud, it might go look up a handful of records and maybe update one or two of them. But you don't know that until the transaction runs. So to prepare for that without Lozen, you tend to move whole data sets. Could be terabytes of information. And not just that, but you're doing it, if there's updates involved, you're doing it multiple times. You're doing it once to get it to the cloud and then once to get it back to the mainframe. So even if you can solve this issue of data concurrency and integrity, you have this big performance issue that this can be really, really a slow approach. So, again, with Lozen, we don't have any of that. The data stays on the mainframe. If I write a transaction that says, go look up Vince's record in this file, the only thing that transfers across your network is that one record. And if I update that, again, all I'm doing is updating that one record, uh, in place in that vSAM file. So, there is no performance delay there. There's never a case where we have to move huge amounts of data over the network to handle that. It's just the records the transactions need to do their processing. So, latency, performance, so all of that kind of stuff can be dramatically better here. And, the way we can get away with that is we don't just provide basic, open, close, read, write access to the mainframe data. We supply the full, let's say the full vSAM API. So you want to do complicated things like, search for a record by its key and then read backwards from that point and then insert a record right in the middle of the file. So absolutely you can do that. All of the complexity and capabilities of vSAM are exposed to your application. So they work unchanged. You don't have to think about, gee, I started with this COBOL program and now I've got to convert it to, I don't know, SQL or something else because it's used to doing keyed reads and writes, and I don't have a mechanism to do that in most environments. With Lozen, you have all of those capabilities, just as you would have if your application were running on ZOS. Like PropelZ, Lozen is designed to be a zip eligible workload. So just like PropelZ doesn't drive the software meter. All the processing it does gets dispatched onto zip engines, and we find that somewhere around 90% of the MIPS that it uses are going to land on a available zip engine. Now, the other thing too is that a lot of a lot of the competing products you might see in this space are based on the idea of APIs and custom coding and that kind of stuff. We require none of that. In fact, we have a demo environment that I would certainly invite everyone on the call to see, and the demo application does the kind of stuff I'm talking about. Read a record by a key, update the record by a key, position to a particular record number, all the things that are common in mainframe applications. And it does that without a single line of proprietary VirtualZ code on the client. So the reason we can do that is because the protocols we use are based on industry standard NFS protocols. NFS is something that's been around for decades, and it's heavily optimized for data sharing. Knows how to do big bulk transfers of data. Knows how to do caching on the clients. It knows how to do serialization and locking, and all the sophisticated things that you expect. So, if you're on, let's say a Linux server and you want to use Lozen, you don't need anything from us. You can absolutely do those through normal file system kind of operations. Now, if you were writing a brand new application from scratch, let's say in Java, we can certainly give you an API and say, here, this will make it easier. Point to this data set name. Here are some methods you can use to do the kind of things I'm talking about. But there's really it's a very open system that way, in that just about any type of application can connect to Lozen. And by the way, that means it doesn't just have to be custom applications that you code. It can be something like, I don't know, third-party commercial software that thinks it's accessing a local file, but what it's doing is reading and writing mainframe, vsam files. We talked a little bit about data transformation, same transformation engine in Lozen. So if I want to read, let's say a vsam file, and I want to see it bit for bit the way it exists on the disk, sure, I can do that. If I want to see it as a JSON object or an XML object or a CSV record, I do that too. I can see the data any way that I want. And and that's probably a little different than many of our competitors. We don't believe in, here's our way of doing it and it's kind of that or nothing. We believe that, depending on the needs of your application, there sometimes are a lot of good answers. And what we want is we want you to be able to access that data in the method that's, easiest, most obvious, and, least amount of work for you guys to, be able to get to the, essential data that you want. So it's not just here's one approach and it's kind of proprietary to us. There are many approaches. Here's an open one. You don't need anything from us. Just use file system APIs. We've also built connectors to different, popular application environments. If I want to take something like, I don't know, an existing COBOL program at the source code level, run it through something like, I always think of it as a Micro Focus product that I guess now is owned by Rocket. You want to take that COBOL source code, compile it, and then just run it under Windows or Linux in the cloud somewhere, but have it access the same vsam files that applications always access. We can give you a connector that does that. You want to use something like MuleSoft or Boomi or Tibco or any of these integration platforms. We've built connectors to those as well. We support the Open API industry standards. So there are, I want to say, about 80 commercial products out there that know how to invoke Open API to, let's say, read a record or update a record. You can use any of that software through Lozen. And what you're really doing is manipulating mainframe data directly with, again, no need to replicate anything, no need to change your application. Just, here's the data, go for it. And of course, one of the side effects of that I probably should have mentioned before is that there's no change in the way your data is secured and managed. If you've got your mainframe security policy controlling who can get to that data, it continues to work exactly the same way. If I don't have access to a particular file, if I can't log into my mainframe and edit that file, I won't be able to do it through Lozen either. So, your existing security policy just works unchanged. A lot of folks on the mainframe side will tell us they're a little concerned that as they move to these new environments, they're making copies or pushing their data out somewhere else. And as soon as they do that, they lose control. They're relying on some other platform to protect the data. In this case, that's not true. In this case, your data stays on the mainframe. So your mainframe security policy is what's going to control access to it. So yeah, really, really an important part of it. So Dusty,
Right.
did I miss
Yeah.
anything or
No, I think you got it all. I'm just going to make a quick again, a little bit about pricing, again, because I think this is really a distinguishing factor in the market. So Lozen, which includes our Java and our C++ API, again, you don't necessarily need that. You can use the NFS client out of the box on the OS, but we do bundle those in as well. So it's $150,000 for the first terabyte. If, again, remember this is very discrete data access. If for some reason you needed additional data, that's something we can talk through. But many customers fit within this 150,000, and then we just charge per connector as well, outside of those original APIs. Obviously, those are very optional depending on your environment, and essentially just a maintenance fee for those. There's no data limits on those as well. Okay, Vince. This one's a very interesting pattern, and it's kind of the opposite, right? Which is, so thinking about how you modernize applications with storage off the mainframe, such as a DB2 table or vSAM, um, or even consuming SaaS data. So let's say you move your ERP platform off of the mainframe, but you still need to share data back from a SaaS application or a cloud application back to the mainframe. Um, uh, and where your mainframe applications are going to generally, the rest of them are going to remain on platform as well. And so, or if you need secondary or tertiary copies of data, that's another very common one we're seeing in the market, especially in this day of ransomware and just additional security. Even if they have something like a um, completely replicated, PPRC, XRC, DASD environment. There's a lot of value to having tertiary or quaternary copies that are available on different clouds or different storage platforms that are very cost effective. So, Vince, can you talk a little bit about how we solve this emerging pattern as well?
Yeah, I mean, the way I always think of this one is, as we talked about PropelZ, it was data in two places. It was data on my mainframe replicated to some type of database. That's one model. We talked about Lozen. Lozen is a model where the data stays on my mainframe and I supply sophisticated access to it no matter where my application is. Zaac is the third possibility there. Zaac is, I have applications on my mainframe, but I want to leverage data that's out in the cloud somewhere. And I should have said this before, but when I say out in the cloud, I don't mean exclusively. It could be an on-prem environment. It could be that you have I don't know, Linux or a Windows server that's 20 feet away from your mainframe. That's your idea of cloud. That's certainly part of the story here too. Um, but with Zaac, what we do is we take that cloud data and we make it appear like any other mainframe storage. It looks to your mainframe applications like it's just more, physical 3390 disk storage or tape storage. And, those virtual tape or disks correspond to, resources that are actually in the cloud. So I can take some Amazon S3, Microsoft Azure, Google Cloud, whoever it is whoever my favorite cloud provider is, I can take their storage and make it look and behave exactly like any other mainframe storage. So what does that let me do? Lets me do some of the things that Dusty talked about. If I wanted to create, let's say a vSAM file or a DB2 database where the storage underlying that is backed by storage in the cloud, I can do that with Zaac. That's our primary use case. You might have let's say you develop a new version of a mainframe application. You need a few terabytes to test it. Um, you don't have to go out and buy more disk. You don't have to upgrade your whatever disk you have sitting in your data center. You can do the same thing on the mainframe that you do on other platforms. You can go to whoever your favorite cloud provider is, say, give me a couple of terabytes, and then treat it as, virtual mainframe disk. So, it's an on-demand model in that case. It's probably pennies on the dollar compared to if you did have to go out and buy, more expensive mainframe storage. And in the case we're talking about modernization, you don't have to think of how do I replicate that to other platforms, or how do I, use something like Lozen to get access to it. I can put that data in the cloud natively, and then it's really my mainframe applications that are processing it. And again, there's no change to my mainframe application. If I've got a COBOL program that thinks it's reading and writing vSAM, continues to think it's reading and writing vSAM. No changes whatsoever. It sees the same data it's always seen, operates same way it's always operated, even though that data is now out in, let's say the S3 cloud. So, a lot of advantages to that. It's also, what we've built, similar to Lozen. It's an open architecture. So, if you tell us, I don't want S3, I want, I don't know, Dropbox, or, fill in the blank. That's just a matter of adding, I'll call it a driver to Zaac that allows us to map our virtual disk protocol to, whatever that target is. And we do that, in an open standards-based way, so that you don't even need to rely on us to provide that. You could develop that, or you could use open source, or you can use, there are a lot of different ways that those needs can be met. We also have kind of opened the door to use of physical storage. Uh, let's say you have a massive investment in, I don't know, an internal SAN that you use for other platforms, but it really has never been able to participate in the mainframe. Well, we can make some of the storage in that SAN environment look like mainframe disk. And again, there's important cost advantages there. If I'm looking to share information between my mainframe and applications that are running in that SAN environment, I can do that too. It's exactly the points we've been talking about here, but where the storage isn't on mainframe. Storage is out in whatever cloud provider that I've got. So Dusty brought up an important uh, use case that's kind of adjacent to app modernization. Things like, what if I wanted to do backups, or prepare for disaster recovery? Well, one of the things we can do in Zaac is we can duplex your data. So it's not just that I have my data in the Amazon cloud. I might have a copy in the Amazon cloud and a copy in the Azure cloud concurrently, so that even if all of Amazon collapsed, had some kind of massive outage, you're unaffected by that. You can have as much of that as you want. You could have, a local, uh, a local device, that acts as kind of a first line of defense, that, in case there's a cloud outage, or, whatever it is that way. So really, and again, it's just network. It's not, very expensive hardware. It's not very expensive, configuration that has to be thought about, and all of that. Just define, here are the targets I want, and the rest just happens like magic. Uh, the other thing I'll mention here is that, one of the common questions we get is, well, how does this perform compared to traditional mainframe disk? And I'll be the first to admit there's no magic in the universe. If I take a high-end solid state mainframe disk that has 16 channels and paths to it, and all the latest technology in every direction, it's not as fast as that. You're going potentially over a network connection here. But we've included a lot of, and actually patented technology that um, allows us to leverage some of the unique mainframe capabilities for things like buffering, for journaling writes to make it fault tolerant, and so forth. So the quality of service that you can have with Zaac is pretty close to what you can have with traditional mainframe disk. Is it faster? Probably not, but when you look at the cost difference and you look at the flexibility and the savings that you get from, gee, I don't have to figure out how to duplex this. I can get that just by using the features of the cloud provider. That's probably a trade-off I think most people would be, pretty happy to make.
And Vince, if you need really high performance and you want to look at the SAN environment, is that really an option? Can we get really close to mainframe performance, on-prem with the SAN?
Yeah, I mean, if you have, so in the SAN environment, we use the iSCSI protocol. And if you have, a reasonable, SAN environment, with fast disks and, multiple high-speed connections to your mainframe, that definitely can put you right within the range of what mainframe storage gets. Again, I don't know, if you got really, really high-end mainframe storage today, I don't know if it'll quite hit that level, but I would say if you've got kind of average performing mainframe storage and a fast SAN environment, which might cost you 90% less, you probably can get roughly equivalent performance out of those two. Will be I mean, this is an interesting question to me personally, and we intend to do a series of benchmarks and blogs and so forth. So I definitely stay tuned for that one, and we'll try and back up what I'm saying with actual numbers that should settle the question for a lot of folks.
Yeah, and Vince, I know we're also looking at some, kind of hardware, software solutions, over the lifespan. So not annually, but over the lifespan of getting, maybe like $1 or under a gig, right? For mainframe level of storage, at pretty high performing levels. So I think that's going to be really fun to see how that develops.
Yeah,
Okay. Oh, yeah, go ahead.
well, I just thought I would share. I mean, the environment we develop this code in includes, a SAN device. It's trivially small compared to what most large enterprises would use, but it in one configuration we looked at, it gives us 180 terabytes of storage for $6,000. And and that doesn't include the network infrastructure and that stuff. But when we think about what 180 terabytes of high-end mainframe storage would cost, that's crazy. And this particular device, in at least in our test environment, we're seeing it. In other platforms, we're able to get 30,000 IOs per second to it without pushing it too hard. So, if we get similar to that with COS workloads, that's a very credible way of having, amazing storage density in a small form factor at a price that, no traditional mainframe storage would ever be able to touch.
Yeah, cool. Yeah, so stay tuned for that. So I'm not going to read, we talked about a lot of these as we went, but just to share some of the key values and to summarize if you're watching this on replay. And then, so let's just take a couple minutes here for a Q&A, and then we'll wrap up. So Vince, I had one question back to PropelZ. I know we talked a lot about kind of VSAM, but can we do DB2 to Postgres or DB2 to Snowflake or something like that? Is that something we can do?
Yeah, that's a great question. So out of the box, PropelZ comes configured to work with basically files. So VSAM files, QSAM files, GDGs, PDSs, Unix services files, all the normal file stuff that you see in COS. But one of the things that we include is that it's really easy to pipe data directly into PropelZ from really just about anything. So, if you wanted to do something like take, the DB2 kind of command line query utility, run a SQL statement, take the output of that and pipe it directly into PropelZ, absolutely you can do that. Using that technique, just about anything on the mainframe could be piped through PropelZ. We have examples where we do things like take system messages from the ZOS operator console, pipe them into PropelZ and store that in a database. It gives us basically a different way of thinking about system automation, based on message traffic. We can do that same thing with SMF records. We can take SMF data that's being produced in real time through PropelZ and into whatever target databases we want. So yeah, a DB2 query, an IDMS query, output of a program that computes, God knows what, all of that is definitely possible with PropelZ. And by the way, same is possible on the other side. I'm talking about the sources or inputs into PropelZ here, but same structure works on the outputs. If you don't want to go to a database, if you want to go to, God knows what, maybe you have an MQ series environment, what you want to do is every record you want to trigger an MQ transaction. You can do that too. It's same idea. The output of PropelZ doesn't have to go to a database. It can go to, be piped to really anything that you want it to be. So it's open on the source side and it's equally open on the target side.
Okay, thanks, Vince. Yeah, if there's other questions, drop them in the chat. I see there's one. Yeah, the recording will be available on both on our website and our YouTube channel, so you'll be able to see that. And then feel free to reach out to us for PowerPoint. We don't post that anywhere, but we can talk offline about that if that's needed. All right, any other questions before? I know we've gone a little long here, and this was a very full session, but I don't want to cut it off. So feel free to, I'm going to wrap up a couple things, but feel free if there's any other questions. So this was the fourth in a series of webinars. 3 of them are already posted out there, and you can re-listen to rewatch them on our YouTube channel or at virtualzcomputing.com. I'll just note, we just talked a little bit about instant mainframe storage and application modernization, but we did a very deep dive one, and that was our most viewed session ever. So clearly there's some interest. We go deeper into some of the capabilities and the use cases around instant mainframe storage. And then in 2 weeks, we have mainframe to tape to cloud migration, which is a really interesting pattern. So Zaac does run in tape mode, but also PropelZ can help with that migration. We have several projects going around that right now. And then finally, we'll wrap up this series for year end. Unified access to mainframe management data like SMF, DB2 logs, console messages, all of those things, both from a kind of an archiving and storage, or if you want to stream those to an observability platform. So that'll be a really unique solution and use case that we'll go through. All right. So we did have one more question. These tools handle IMS DB as well. Vince, you want to take that one?
Yeah, well, so for PropelZ, it would be the same answer we talked about. So far it's open on the input and output side. So if you wanted to, you have an application that can read whatever IMS structures it wants. You could run that, take the output of it through PropelZ, and do whatever you like with it. So, yes, in that regard, PropelZ is probably the easiest one. For Zaac, because Zaac is emulating virtual disks, you can certainly use a Zaac virtual disk for an IMS database. That's part of it as well. Zaac doesn't really care what that structure is and how you do I/O to reference it. So that's good too. With Lozen in between, Lozen is kind of designed with that same idea of almost like a plug-in architecture that allows us to add different support for different environments on the mainframe. Today, out of the box, Lozen comes with file support, so VSAM, QSAM, sequential files, GDGs, PDS, all the things I mentioned before. If we wanted to do IMS, that would be an enhancement. The structure is there to allow for that, but at least so far we haven't had the business case for doing that. So, if that's something that would truly be interesting to you, by all means, get in touch with us. We're happy to kind of go into that in more detail to understand what those requirements would be, and we can give you an idea what that would look like.
Yeah, and as Vince said, right, we've had this conversation with a number of customers and partners in the past, and it's completely possible. But again, it just is, we got to make sure there's the right business case and use case to drive forward, and it creates the value for that customer that's worth it. So, but yeah, we're happy to discuss it. We've been down that path before. All right, I'll just mention a couple of final things and wrap up. So we've got a lot of resources out there. So we do webinars, we've got demos, blogs. So we're trying to produce as much content to meet customer and partner needs. And so there's a lot out there to go take a look at and hopefully find your use case. If you don't, just reach out to us and we'd be glad to take topics. With our 3 products, we can cover just about any use case out there. Again, largely because of the architecture that we have and the flexibility that's been built in by Vince and his team. Thank you for joining us today. We hope you'll join us for a future webinar as we wrap up this series or into next year. Have a good day.